In this segment, we will be discussing the recent tragic earthquakes that have left Haiti and Chile searching for answers. We are honored to have the Deputy Director of the Southern California Earthquake Center, as well as the Department Chair of Geophysics at Stanford University, seismologist Dr. Gregory Beroza, to help us get some of these answers. Thank you for joining us, Doctor.
Thank you for having me.
So, to start out, I was wondering if you could help our audience understand how earthquakes occur.
Yeah, I'd be happy to. Earthquakes occur because the Earth is an active planet. The Earth's surface is covered with a set of large shells that we call plates. They're about 60 miles thick and up to thousands of miles across. These plates are moving relative to each other as the Earth tries to get heat out of its interior and cool material into it. Basically, it's a way that the Earth cools off. In most of the time, these plates are stuck. That is, at their boundaries, there's friction that keeps the plate boundary faults from moving. Every once in a while, the friction is overcome by the stress that builds up with time. And when that happens, the two sides of the fault slip suddenly. And it's this sudden slip that generates seismic waves that propagate to the Earth's surface that we feel as the shaking in an earthquake.
Well, what are some examples of different types of earthquakes? And do we experience all different types of earthquakes, particularly here in California?
Yeah, so there are three fundamental kinds of earthquakes. There are what we call strike-slip earthquakes, where the two sides or two plates move horizontally past one another. The San Andreas Fault is the sort of the type example for that. The material to the west of the San Andreas Fault is moving to the northwest relative to the interior of North America. Another kind of fault that occurs is what is called a normal fault. That's when plates are pulled apart, and the slip on that kind of fault goes sort of like this. It has a vertical component. It's not purely horizontal. The third kind is when the two plates are converging. They're coming towards one another. The earthquake in Chile that happened just this year is an example of one of the very largest of those kind of earthquakes.
Indeed.
And to answer the second part of your question, we do get all of these types of earthquakes in California. We tend to focus on the biggest fault, the San Andreas Fault, which is strike-slip.
What is the difference between the magnitude of an earthquake and the intensity?
Yeah, this is a good question. It's something that seismologists are very particular about. We use those words in a particular way. The magnitude is a measure of the intrinsic size of an earthquake. So the earthquake in Haiti that happened on January 12th, that's a magnitude 7.0 earthquake, no matter where on Earth you recorded that earthquake. The intensity is how strong the shaking is, either as perceived by people or as it affects buildings and things like that. So that depends for a given earthquake on how far away you are from it.
Okay.
The analogy I like to use is a 100-watt light bulb. The wattage is like the magnitude. It's a 100-watt light bulb no matter where you see it. If you're close, it's bright. If you're far away, it's weak. That's the intensity.
Okay. Clearly, better predictions in regards to earthquakes will help us save more lives. Are seismologists such as yourself any closer to developing models that can come closer to saving more lives?
Well, you put it that way, then yes, we are. That doesn't necessarily mean predicting the exact time and place and size of an earthquake. That's something that's very hard. We know that now. It may be impossible. I have a whole public lecture on that on iTunes U. You can download it for free. Suffice it to say, that's a very difficult problem. But the sort of things we're focusing on now, more than prediction, I would say, is trying to predict how strong the shaking is in close to big earthquakes. That's something we have very little data on, and it's fundamentally important to earthquake-resistant building.
Okay. Well, we're on our way.
Mm-hmm.
So I'd like to ask you real quickly, are most tsunamis, because we know there was a tsunami that occurred in Chile, as well as an earthquake, are most of tsunamis related to earthquakes?
Yeah, so tsunamis occur due to a sudden displacement of the ocean floor, sudden displacement of water in the ocean. The most common source of tsunamis are large earthquakes, like the one that happened in Sumatra in 2004. Large volcanic eruptions, if they occur underwater or if they explode into the water, can have the same effect. The Krakatoa eruption of 1883 generated a gigantic tsunami.
The earthquake that recently hit Chile had a magnitude of 8.8, and there was a very significant low death toll compared to Haiti, which was a 1.8 difference from a 7 to the 8.8. There was as many as 230,000 lives lost in Haiti, and in Chile, there was as many as 452 reported by the Associated Press. Could you explain why so many people were left with more losses in Haiti compared to Chile?
Yeah, there are a couple of factors. First of all, in terms of the magnitude scale, the 8.8 earthquake releases 500 times the amount of energy as a 7.0. So the Chile earthquake is just almost 1,000 times bigger than Haiti. So the question is why? Your question is why was Haiti so much worse?
Yes.
There are at least three factors. One is that the slip on the fault in Haiti was shallow. It was right up at the Earth's surface or near the Earth's surface where people live. And so the waves didn't travel as far before they hit the buildings. Another factor is that the fault that ruptured in Chile is hundreds of miles long, whereas the one that ruptured in Haiti is a few tens of miles long. Okay. So the intense shaking is focused. And in this particular case, unfortunately, near a very densely populated city, Port-au-Prince. And the third, and probably the most important factor, is the building practices. The buildings in Chile, they've had a lot of earthquakes. They have good building codes, and they enforce them. In Haiti, they have infrequent earthquakes, and the building codes are not, such as they are not really enforced. And that's the biggest factor in the difference.
Okay. Are the earthquakes from Haiti and Chile, are they related in any way?
We don't think so. They don't. Each of those earthquakes involves two of the tectonic plates. So the four plates involved in those two earthquakes are different plates. They're very distant from one another. It's possible that earthquakes can influence the occurrence of other earthquakes over large distances. We've seen that for very tiny earthquakes. We haven't seen it definitively for big earthquakes. So I think for now we'd have to say that those two earthquakes are not related.
If that strong of an earthquake that hit Chile were to hit California, not any particular area, but California in general, what kind of damage would we be looking at?
Well, I would say that kind of earthquake, we don't expect an earthquake that big in most of California. The San Andreas Fault could support an earthquake perhaps as large as magnitude 8. But it's a narrow fault, and unlike the fault that ruptured in Chile, the one place in California where we could get a really gigantic earthquake like that is the very northernmost part of California, so up by the Oregon border. And that we think that area may have had an earthquake of about this size, that is about magnitude 9, in January 1700. It's unclear what the what the effects would be. We would feel it down here, but it wouldn't. I don't think it would be causing damage in the urbanized parts of California.
So that kind of leads me into my next question, and I'm sure everyone in the Bay Area will be very interested to see how you answer this. It is my understanding that we are overdue in the Bay Area for quite possibly a huge earthquake. Is that true? And what is your opinion on that?
Yeah, so overdue is a little bit of a tricky way to phrase it. Earthquakes don't happen on a schedule. We can't predict them. We know that when faults, we know when a fault has accumulated enough stress for an earthquake to be possible. And in that sense, we don't think in Northern California that we're ready to have a really big one like the 1906 earthquake, which was magnitude 7.9. So much stress was relieved in that earthquake. We think, it's my opinion, that we're not ready to have an earthquake that big. However, we have enough stress to support an earthquake as large as the earthquake that happened in Haiti, in the Bay Area. We think there's something like a 2 out of 3 chance of an earthquake, magnitude 6.7 or larger, happening in the next 30 years, sort of that time frame. So if you live in the Bay Area, given that we can't predict earthquakes in the short term, you should prepare.
That concludes this segment of the Bay Today. show written and produced by the students of College of San Mateo's Broadcast and Electronic Media program. A very special thanks to Dr. Gregory Beroza for taking this time out of his busy schedule to help us understand earthquakes better and share his insights. For more useful information on earthquakes, please visit earthquakecountry.info. Thanks for watching, and we'll see you next time on The Bay Today. Thanks again.